Okay, so we are live now. Let me share my screen and let me start the discussion for week 4. Okay. Okay, so okay, all right then. Can you see my screen?
No, sir.
Yes, sir.
Yes.
Yeah, I.
Oh, okay, fine. So we have discussed, some. So in week 1 we started with, in starts when you have seen something about, single random variable, right? I mean PMF, PDF, CDF, and all. So
Yes, sir.
in week 1 you have seen joint PMF for two random variable. Then in week 2 you moved on, function of random variable. Then in week 3, uh, I mean you have done about, expectation, variance, and all things, correlation, covariance about discrete random variables. So I mean, suppose this is your x as a discrete random variable. Okay. So about this, you have studied till week 3, right? Okay. So now we will move on about continuous random variable, right? So what? Let me give you some idea. Then we will start things. So you have seen the PMF of a discrete random variable, right?
Yes.
Yes.
Right. And if you know the PMF, all right. So if you know the PMF, you can find the CDF of that random variable or not.
Yes.
Okay. And so there is a bridge. So this is about, I can say as a, this is something you can consider as a discrete world. Okay. So we will see a bridge from PMF of a discrete random variable to CDF of a discrete random. This is something we have done. And we will see from here to here as CDF of, I'm writing CRV for continuous random variable. Then we will move on PDF of continuous random variable. Okay. So PDF stands for probability density function. We will see in a couple of minutes. So this is something you can treat as a continuous. Okay. So this is a bridge, you can say. This CDF plays a bridge between this discrete world to continuous. Okay. Do not worry about this. Now let me start. Okay. So maybe you have seen the PMF, right? PMF of a discrete random variable, right?
Yes, sir.
Give me a minute.
Is her screen frozen?
No, actually, yeah. Now can you hear me?
Yeah, yeah.
Yes, sir.
Yes, sir.
Okay. All right, great. So we have seen the, okay, what PMF tells us. Any thought? Whatever you have done so far, just give your thoughts.
That sums up to be equal to no
That
1.
is something you are telling me, properties of PMF. No, I'm asking what PMF tells us. What?
Probability of getting that event.
Probability of getting that discrete
Oh,
variable.
mass. Okay, sorry.
Yeah,
sorry.
it's a kind of probability mass function. Basically, it's a probabilistic behavior at each values of your random variable, right? So what I mean by probabilistic behavior, suppose x is the random variable and it takes the value, let's say x1, x2 up to so on till xn. Okay. So what I mean by probabilistic behavior, what is the probability that random variable x will take value x1? Let's say it's a p1, it's a p2 up to pn, right? So this is something probability mass function we have done, and there is two properties for being a valid PMF is what? All the probabilities should be greater or equal to 0, and second one was addition of all the probabilities should be equal to
1.
right. This is something we have done already, right? Okay. And what about CDF? What's the role of CDF? It stands for cumulative distribution function, right? And what it does? So okay. Anyone, any thought? What's the role of CDF?
Less than equals to 7. We use it to calculate the probability less than.
Basically, it accumulates all the probabilities, okay, till a particular point, right? Yes or no? Let's say that point is A, for example. So what I mean by this, so I'm interested to accumulate all the probability till a particular point A. That means, suppose I'm saying, what is the probability that x will take value less or equal to A? This will, I'm going to represent as a f of A. What okay, let's say, suppose I'm asking what is the probability x will take value less or equal to x2. That means what you will do means I have to add the probability x equal to x1 plus probability x equal to x2, right?
Yeah.
So what you are doing here, and what if I will ask probability x less or equal to x3, means x will take x1 plus probability x will take value x2 plus probability x will take value x3, right? That is something we have to do, correct? So what you are doing, we are accumulating all the probabilities till that particular point x3. Yes or no?
Yes.
So that is the idea behind your cumulative distribution function. Means in CDF, you are not interested in a probability at a particular point. You are interested in a probability till a point. Yes or no? Clear?
Yes.
Okay, fine. Suppose I'm saying x follows uniform distribution, let's say 0, 1, 2, 3 up to let's say 10. Okay. Suppose I'm asking what is the, okay, tell me what is the probability x will take value 0?
1 by 11.
1 by 11. This is okay for everyone. What if probability x equal to 1?
Same one.
1 by 11, right? And so on. If I will ask probability x equal to 10, it will be again 1 by
11.
right. Now tell me
Yes.
what if I will ask probability x less than or equal to 2?
3 by 11.
Okay, this means
3 by 11.
what you have to do? We have to add probability
P
x equal
of
to 0.
x equal to 0, x equal to 1, and x equal to 2.
Correct, right, till 2. So it will be 1 by 11 plus 1 by 11 plus 1 by 11 equal to, I can say this is 3 by 11. All right.
Yes.
Now tell me what if I will say probability x less or equal to 3. That means I have to add probability x equal to 0 plus up to
4 by 11.
probability x equal to 3. It will be 4 by 11.
Yes, sir.
Right. Okay. Can you tell me what if I will ask probability x less than or equal to 2.5?
Sir, it will up to probability of
3
x
by
equal to 2.
See, that means probability x equal to 1
2.
plus probability x equal to 2 only, right? Suppose I'm asking probability x equal to 2.5, for example. But for this, we do not have any probability, right?
Yes, sir.
Correct.
Yes.
So this will be again 3 by 11. So if
Yeah.
you will observe carefully this value, okay, this value and this value. So there is one property for CDF, which tells us CDF is a non-decreasing function. Is it clear? Why? What is the meaning of that property? Let me write here. Properties of CDF. So first one is f x of x. So this small x is one of the value for your random variable capital X. Is a non-decreasing function. So what do you mean by non-decreasing? Either constant or it will increase, right? Would you agree with me?
Yes, sir.
Right. So you can see, if you can verify from here. So this value is either constant, right? Either it will increase. Okay. Similarly, you can cross check if probability x less or equal to 4. So it will be 5 by 11, right? Which is higher than 4 by 11. Is it clear? So
Yes,
that means
sir.
what you can say, if x1 is, what do you mean by this? So you can simply say if x1 is the one of the value for your random variable less than x2, then you can say capital F of x1 is less than capital F of x2. Clear?
Yes, sir.
Okay. Now, what is the second property for of a CDF?
It's always between 0 and 1.
It's always between 0 and 1. Okay.
Its maximum value equal to 1.
Yeah, maximum value. That means yeah, that the same thing. It will always lies between 0 and 1. Okay. So how will you cross verify that part?
X tends to
Okay. Let me write one more property. You can say. So there is one more property. If x less than, I mean not less than, x tends to minus infinity. Okay, we will see this property. Fx goes to 0, right? And as x tends to plus infinity, fx goes to
1.
one more thing you can say, fx lies between, I mean range of fx is nothing but 0 and 1. We will check in a minute. So you had this concept. What if I will ask probability x less than 0?
0.
Sir, 0.
0.
There is no probability, right?
Yes, sir.
What if I will ask probability x less than -2?
0.
It's
0.
also
0.
0.
Probability x less than or equal to -13,
It's also 0.
right? So can I say whenever x is tends to minus infinity, means then it will tend fx goes to 0.
Yes, sir.
Okay. Now,
Sir, but
yeah.
this is not necessary now. If discrete random variable take input as negative integers, then we have to
Yeah,
solve.
then it's a fine, right? So suppose, okay, suppose take, okay, lower limit is -1, for example, suppose. Okay. Then if I will take x less than -2, then it will be 0, right? That's what I'm trying to say. Okay. Okay. Basically, if you, okay, let's focus on this. So range fx lies between 0, I mean
0
the
to 1.
0 to 1, right? Let's cross verify this. Okay. So what if I will ask a probability x less than or equal to 10 in this case? 0 to 10.
Yes, sir. It will be 1.
It will be 1.
1.
Yes or no? Right? Because you have
Yes,
to
sir.
add all the probabilities.
All the probabilities from 0 to 1.
Correct.
11. 10, 10.
10.
It will be 11 by 11.
11 by 11 equal to 1.
What if I will ask probability x less or equal to 12?
Sir, it will be 1.
1, right? Because
Yes,
till
sir.
10, I mean summation of all the probability x equal to 0 plus probability x equal to 1 plus probability x equal to 10. You know this is 1, right? And if you will add probability x equal to 11 plus probability x equal to 12, and we know this probability will be 0, right? Because we don't have
Yes.
any info,
Yes,
right?
sir.
So this will be again 1, right? So now this
No, it will
property,
be 0.
ah, total, I mean total.
Okay,
This
okay.
will be 0, total add up to 1. Okay.
Okay.
Okay. Now, Okay, so this is clear, right? This some sort of about
Yes, sir.
CDF things
It
clear?
is clear.
Okay, now let's start the plotting. I mean, how to plot the CDF graph. Okay, now
Excuse me, sir.
yes.
So how is it 1? It should be 0, right?
No, this is 0. This is 0, but this total is 1, right?
Oh, yes, sir.
So 1 plus 0 is 1, right?
Oh, got it.
Okay. Yeah, okay. Okay, so there is one more thing. Then I will move on the one more property that's you can say. So probability A, okay, less than X, less or equal to B. This is something I can
F
write
of B
as a
minus F of A, sir.
probability X less or equal to. Okay, before going to that, you will tell me how to. Okay, suppose I'm interested to find out this probability. Okay, so for example, let's say A is here and suppose B is here, and I'm interested to calculate this X. Suppose X is here, and I want to calculate X more. I mean after A, but less or equal to B. So what does this mean? This means I'm interested in let's say after A means from here till B, right? Yes or no?
Yes, sir.
Right?
Yes, sir.
How I can find this part? If I
Sir, B
can,
minus A.
suppose if I'm going to suppose this is the total part, for example, okay. If okay, let me redraw. If I will subtract this brown region, okay, from the red one, I will get the green part,
Yes.
Yes, sir.
Yes, sir.
right? So what is the red one?
Sir,
Brown
B,
plus
sir.
F of B.
So probability X
Probability
less
X
or
is
equal to B,
B.
yes or no?
Minus
And what is
probability
the
of
brown
A.
one? Minus
Minus
probability X
probability
less
of
or equal
X
to,
less than equal to A. Yes,
fine.
sir.
So I can simply write f of B, fx of B minus
Minus
fx of,
Fx of A.
but make sure here equality sign matters in case of discrete. We will see in case of continuous also. So if this part you got, okay. Now by using this information, if I will ask what is the probability that let's say A less than or equal to X less than or equal to B. So how will you proceed? So from here you can get an idea, right? So this means what? Okay, can I write? I have information about A less than X less or equal to B. Yes or no?
plus probability of A.
Correct. If I will add probability X at A, then this equal to less than or equal to sign I will get.
Yes, sir.
Everyone is
Yes.
okay. Everyone is getting my point.
Yes, sir.
Yes.
Okay. Now suppose this is some point. Let me make it as an arrow. What if probability A less than or equal to X less than B only?
We can subtract it.
So okay, you okay. How will you proceed?
So we have this
We can
A equal
add.
to X equal to B
Okay, so
minus probability of X equal to
correct.
B.
So you have information about this, right?
We can add
How we can
probability of
proceed? A less than or equal to X less than or equal to B. You can see here there is no
minus
equal to
probability.
sign. Correct. So I will subtract probability at X equal to B. Okay. Something you can calculate and you will get. What if probability A less than X less than B?
Then we can use first equation.
Sir, we have to subtract both X equal to A and X equal to B.
See, you have this information, right? If I will subtract X equal to B, I will get this part. Okay.
Yes.
This equation is clear to all of you. Okay.
Yes.
So here you can
Yes, sir.
see equality sign, matters in case of discrete random variable. Okay. If that is clear,
Sir, can we discuss why the difference leaves out probability at A?
Sir, and
Yep.
what is the base case, sir?
You see,
Which we should remember.
so you can remember this part. Okay, just remember this
And
part.
based on this part, we can calculate the other
Correct,
parts.
correct. No need to memorize all these four. Okay.
Okay, okay.
If you know these
That means
things,
the number 4 is a base part, and we have to keep that in mind.
correct, correct. So this part you
Okay.
can keep in your mind. Others also, this thing you can calculate with this part, right? This region and all. Simply you can draw
Okay,
and
sir.
okay. Then based
Yes.
on this, since it's a discrete random variable, right? So equality sign matters, right? Means
Matters.
probability at a single point will matter. Okay.
Matter.
We will
Okay.
see the same case. I mean, similar case probability at a single point in case of continuous will be 0. How will it will be clear in a minute. Okay, so I took one of the example. X follows uniform 0, 1, 2 up to 11, right? So let's draw the CDF graph, okay, for this part. Okay, so this is your X and this is will be your capital F of X, and suppose this is your 0, this is let's say this is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, 9, 10. Okay, so what is the probability when X will take value, I mean X less than or equal to 0? X less than or equal to 0?
0.
X less than or equal to 0?
So 1 by 11.
I'm asking X less than or equal to 0.
1 by 12. Yeah,
1 by 11, right?
Yeah.
Okay, let's
Yes, sir.
let's take it that let's make it 10. Yeah, 1 by 12 is correct. When I
Okay,
took
okay.
10. Okay, now it's 1 by
Yes,
10.
sir.
Yes or no?
One by-
Okay, before this it will be 0, right? Yeah, before. Okay, if I will ask probability X less than 0, it will be 0, right?
There interval 0, sir.
Yes.
Yeah. Okay. So from
Yes.
here, let's make it as let's say this is 1 by
1 by
11, and suppose this is 2 by 11. Suppose this is 3
Up
by
to
11.
1.
This is 4 by 11. This is 5 by 11. And suppose this is the 1.
One.
Okay. Scaling we have to adjust actually. I'm just
Okay.
trying to give you idea. So what if probability X less than or equal to 1? If I will ask probability X less than or equal to 1.
So 2 by 11.
2 by 11.
Okay, if you want to find the region for this is 1 by 11. That means what? Can I do like this?
Yes, sir. GIF
Yes or no?
like graph.
If I will ask probability X less than or equal to 1, that is probability X equal to 0 plus probability X equal to 1, which is nothing but 2 by 11. That
1.
means what? So it will be close point for 1 and light circle at 2.
Open point on 2.
Right? Similarly, probability X less or equal to 2, it will be 3 by 11.
Yes, sir.
Yes or no? Then 4 by 11.
Yes, sir.
And so on up to it will go to 11 by 11, which will be something like this at 1 onwards. Like this. Okay. Okay. This graph is clear to all of you,
Yes, sir.
right?
Yes, sir.
So what if I will ask probability X equal to 1? How will you calculate?
The jump.
The probability
That is
of
jump, right? So probability X equal to 1 is nothing but this jump. And what is this jump? 2 by 11 minus 1 by 11, which is nothing but 1 by 11. And from the uniform distribution, it is clear, right? Probability at a
Yes,
single
sir.
point, probability X equal to 1. Okay, can I write like this?
Yes,
Probability X equal to 1 as a probability X less than or equal to 1 minus of okay. What I can write if I am writing like this, probability X less or equal to 1, can I write minus of probability X less than or equal to 0? That will give you this part.
Yes, sir.
Would you agree with me, everyone?
yes, sir.
Okay.
Yes,
Now,
sir.
what if I will ask probability X equal to 2? That means this jump this will give you probability x equal to 2 or not. This will be again 1 by 11.
Yes, sir.
Means 3 by 11 minus 2 by 11. And how I can find this probability x equal to 2? If I will subtract x less than or equal to 2 minus probability x
Minus
equal to...
probability x less equal to 1.
Yes or no?
Yes, sir.
Yes, sir.
Okay, everyone is getting this point, right?
Yes,
So
sir.
that
Yes.
means, can I generalize if I'm interested in case of discrete probability at a single point from the CDF? Can I say probability x less or equal to a, okay, minus probability x less than or equal to a minus 1
A
or not?
minus 1. Yes, sir. Yes, sir.
Can I say this part?
Yes, sir.
Right? Everyone is getting right. You can simply say yes, no. Only then
Yes,
I
yes,
will
yes,
I
sir.
will get idea
Yes,
whether you
sir.
are
Yes, sir.
okay.
Yes.
So in case of discrete, so you can say see simply there is a jump, right? If I'm interested to calculate probability at a single point, that single point is nothing but jump, right?
Sir, I have a doubt.
Hmm.
So discrete values can only be integers or it can be decimals also,
It
like
can be
a
decimals
fixed
also.
number.
It can be decimals also, right? That's not okay. It will depend on the how you are going to define your you know uh, discrete random variable actually. Okay.
Oh, okay.
Okay. So I mean there are some examples
Like
like okay,
currency.
currency you can currency, but
Like,
you no no, you have to define specifically then.
okay.
Okay, so basically suppose you have coin of some, let's say you know, okay, one more thing, that random variables, suppose it should be you are able to count. Okay, for example, let me take some example. Maybe let's say suppose you have coin of 1 rupees, 2 rupees, 5 rupees, for example. And okay, maybe have you seen about I mean the coin of 50 paise something,
Yes, I have.
Yes,
right?
sir.
Suppose I will ask I want to, you have defined your random variable such that you have rupees 1.5, 2.5, 5.5, something like that, right? So the key thing we have to understand about discrete, you can it should take this, you know, distinct value on real number line. Okay, suppose even it's in decimal, suppose it is taking 1.5, 2.5, 5.5, not any other value possible between this interval and this interval, and you are able to count my random variable x is taking value this value 1.5, 2.5, 5.5, something like that, right? You will go for the discrete, right? So thing is that if they can take lots of value between a given interval, then it will be your
Continue.
continuous. Okay, so
So
this
can
video
we
is
say
this
rational numbers?
which number?
Rational numbers,
Rational number is will become no,
continuous or discrete?
yeah,
Discrete, right?
no, how?
Um, like 1 by 4,
Hmm.
0.75.
Yeah,
That
what
is
about 1 by 3?
no, that is not a rational number, right? Is that a rational number?
That
Yes.
is
Okay, how will
any
you define the rational number first of all?
Oh, that
any
is
number can be defined in the
Any
form of
fraction
p
p
by
by
In the
q.
q
the form of
and
p
q
by
is
q,
not
right?
0.
Yeah, q should be greater than 0, right?
Hmm.
Okay. Yeah, that is different thing, right? So actually,
Yes,
yeah.
sir.
it will depend how you are going to define your random variable. The key thing you have to observe, it should take, you know, distinct point on real number line, and you are able to count. Maybe suppose you have defined your x random variable as let's say 1.1, it will take 2.1, 3.1, 4.1, something like that, right? And it is not going to take any value between these two intervals, something like that. Okay, this is something you are able to count. Okay. Okay, but
Yes, sir.
in most of the cases, we have seen discrete as a integer. That's why we have generalized as a integer, but which is not true in all cases. Okay. Yeah, someone has raised hand. Yes, Kusal.
Sir, the graph representation will always be the greatest integer graph, like that pattern will be followed.
Function.
Can you come again?
The greatest integer function means the pattern of that graph will be same as the graph which you have represented here. No?
It's only for discrete random.
Yeah, this is only for discrete. Okay. So okay. so far this part is okay. How you can calculate probability at a single point and all.
Yes.
Is this all
Yes,
right?
sir.
Yes,
Along
sir.
with the
Yes,
probability.
sir.
Okay.
Is this okay,
So
sir?
okay. Suppose I will ask in the same. Okay. So let me take another example. Suppose I'm saying x follows uniform rather than 10. Let's say 1, 2 up to 50, for example. Then what kind of your graph will look like? Okay, so suppose this is x, this is capital F of x. Suppose at the top, if this is 1, okay, and if this is the 50, then values will be 1 by 51. Yes or no? 2 by 51, 3 by 51,
Yes.
4 by 51, 5 by 51, right? Something
Up
like
to
that.
1.
So
Yes.
0, 1, 2, 3 up to 50.
50.
Okay, so graph will be something like this.
Yes.
Yes or no?
Yes, sir.
Okay,
Yes, sir.
Yes, sir.
and from here it will be 1 onwards, right? Okay, what if instead of 50, let's say I'm going to take for, let's say, uniform 0, 1, 2 up to 100. Okay, suppose this is 100. Then what kind of graph will look like? So this is your x, this will become your f of x, and this is 0, 1, 2, 3, 4 up to, let's say,
100.
100, right? And what will be values here? 1 divided by 101,
1.101.
right? 2 divided by 101, 3 divided by 101. Similarly, 4 divided by 101, 5
So
divided by
the
up
jump
to,
will be minimum.
right? So your graph will look like something like this, right?
Yes, sir.
Yes or no?
Yes, sir.
So even you can see, I'm able to, this will be 1 actually. So here you can find the probability at jump, right?
Mm.
Okay. So thing is, suppose instead of 100, you have increased at, let's say, 500. Okay. If your axis follows, uniform 0 up to, let's say, 500, then your graph will look like something like this. Let's say this is x, this is capital F of x.
So the
It will
jump
be
will be
0,
closer.
1, 2, very minimal, less,
Yes,
right? So
sir.
it will be 1 divided by 5 not 1, 2 divided by 5 not 1, 3 divided by 5 not 1, and up to 1, right? So your graph will look like something like this, right?
Yes, sir.
Everyone is
As you
getting my
increase
point,
the
right?
number of points. Yes,
So you
sir.
can simply see whenever you will increase the numbers, right? There will be very minimum jump, right?
Yes,
Between,
sir.
I mean, for each values of your random variable x, right? So the key idea is whenever you will increase n, right? So you will get, for sometimes you will get graph like this. Okay, all
Yes, sir.
right. In that case, suppose there is one point, this point. If I will ask, let's say this is some let's say a. If I will ask what is the probability x equal to a, will you able to find this probability? Yes,
Yes,
no?
sir. The probability of
Zero.
x less than equal to
0.
No,
a
sir.
minus probability of
Okay. Tell me one thing. Here, how did you find the probability at x equal to 3? You simply subtract. You simply find out this jump, right?
yes,
You
sir.
simply subtracted this value to this value, right? But in this
Mm.
case, whether it is possible,
No, sir.
so you can see there is no jump, right? Yes, no.
Yes, yes.
Yes, sir. Yes, sir.
Correct.
Yes,
If
sir.
there is no jump, that means what? Probability will be 0 here.
Yes, sir.
Yes.
I mean, is
Correct.
it if it is discrete, then there is something, but
Correct.
considering you are taking uniform example.
Yeah. If even you can take binomial, geometric, and all. So thing is, discrete means what? The key idea is to understand it. Discrete means what? There will be jump. If you have discrete random variable, there will be always jump. Because of that jump, basically that jump tells us the probability at a single point, right? That is something we have seen here. Yes or no? Probability at x equal to 1 is what? This jump. Probability x equal to 2 is what? This jump. Probability x equal to 3 is what? This jump, right? Similarly, you can see in this case, jump will be minimum, right? If you'll increase
Yes, sir.
100, again you will get very minimal jump, right? If you'll increase 500 or 1000, something like that, so at some point of time, you will get no jump, right? You can approximate as a no jump. So you can simply
Sir,
see
it's
if,
like continuous.
yeah, that's what I'm
So
trying to say here.
it
Okay.
is not exactly no jump. It's like tending toward no jump, right?
Correct. So it's a approximating. Basically, you are going with the continuous word, right? In discrete, we are able to find the jump, while in the continuous, there is no jump, right? Okay. Suppose you have increased till 5,000, something like that. Okay. Let me take one more example. Maybe suppose I'm saying x follows binomial random variable. Let's say with 10 comma with probability half. Okay. What if I will ask probability x equal to 3? You can simply calculate, right? What it will be? It will be 10c3 half raised power 3 half raised power 7. Basically, it will be
7.
10c3 half raised power 7, right? What if I will ask probability x lesser equal to 4?
Sir, that would be half raised to the 10.
Okay. What if I will ask probability x lesser equal to 4? That means you have to add probability x equal to 0 plus probability x equal to 1 plus probability x equal to 4. Yes or no?
Yes, sir.
Right?
Yes, sir.
So then you can easily calculate. What if I will ask x follows binomial, let's say 10,000 comma half, and in that case I will ask probability x less than or equal to 9,900 something, let's say 9. Okay. So how? Okay. What will be your approach? Tell me.
I know 0.
Sorry.
Sir, 1 minus probability greater than the number you have written.
Yeah. Someone has raised hand. Yes. Do you want to say something? Yes. Yes. Yeah. Go ahead. Do you want to say something?
Sir, 1 minus probability of 999 and 10,000.
Okay, that's okay. What if I will ask probability? Okay, that is something you are explaining with the concept. Okay, if you want to add probability x equal to 0 plus probability and so on plus probability x equal to 9998. So this is something, it's a, something difficult task or not? I mean, there is a
No,
chance of
sir.
making error.
Yes.
Yes, sir.
Yes or no? Okay.
Yes,
So
sir.
it
So
will be very hectic.
correct.
Task,
So
sir.
it's in this kind of scenario, it's good to go with the continuous word. Means what I mean by continuous means you can simply approximate the part. Means you okay. So in this case, what will be there? I'm okay with some sort of error, but no. You can simply you can say like this. You are okay with some sort of error, but I mean your time will save. Yes or no?
Yes.
Okay.
Sir, we want to have the approximate.
Basic. Okay. So okay. Let's make it simple. So what I'm trying to say, for continuous random variable, your n will be large. Okay. That is something you can see here, right? Whenever you will increase your n, there will be no jump in your graph, CDF graph. Yes or no?
Sure.
Yes, sir.
Yeah. That is okay or not? This CDF graph, from this CDF graph, it is clear.
Yes, clear.
Yes, sir.
Okay. Now, so if this is okay, so one more thing you will tell me. Suppose I will say rather than probability at single point, if what if I will ask probability between 2 points? Are you getting my point? So suppose this is the case. Okay, suppose for example this is 40. Okay, just assume. Okay, this is 40, and suppose something there is some 60. Okay, and I will ask what is the probability x. I mean your random variable will take value 40 and 60. This is something I can calculate from here,
Yes.
Yeah.
Yes, sir.
right?
Probability x is greater.
Yeah, that is the different thing, formula and all. I will tell you the formula which we have seen, the importance of that formula actually, probability and all. So that okay, one formula we have seen, probability A less than X less or equal to B. What was that? Probability X less or equal to B minus probability X less or equal to A. Yes or no? That is something we have seen, right? Let's
sir.
verify others point. Okay. So first of all, before let's summarize this continuous word thing. I mean CDF of continuous word. If you have continuous, right? So first of all, your fx of x means CDF things has no jumps. Okay. So no jumps means what? Means probability, if you want to find at x equal to any particular point, it will be 0 for any a, right? Second thing we have seen in case of discrete also, if you want to calculate a less than x less or equal to b, this is something we calculated as probability x less or equal to b minus probability x less or equal to a. Yes or no?
Yes,
That
sir.
is something we have seen fx
Yes,
of
sir.
b minus fx of
Fx of
a.
A.
And okay, what if probability a less than or equal to x less than or equal to b? In case of discrete, how we proceeded? We proceeded like this: a less than x less than or equal to b plus probability x equal to a, right? Because
Yes,
you can
sir.
see the equality sign here, right? But in case of continuous, here I'm going with the continuous random variable. In case of continuous, probability at a single point will be
0.
right.
0.
This is again f of b minus f of a,
Yes, sir.
right?
Yes.
If I will write probability a, I know less than x less than b, then you have this information. Probability a less than x less than or equal to b. I should subtract probability x equal to b, right? If
Yes,
suppose
sir.
in case, okay, this is the I mean basic approach, right? And we know in case of continuous, probability at a single point will be
0.
again f of b minus f of a,
Yes, sir.
Yes.
right? If I will write probability a less than or equal to x less than b, okay, so you have this part, right?
So that
Probability
will be equal to the same. F
less
of B minus
a
F
less
of
than
A.
x less than b, 1 minute. So I have to add probability x equal to a only, then I will get this part. But in case of continuous, probability at a single point is 0. Again, I will get f of b minus f of a. So in case of continuous, you can see for each part, probability is this is same, right? F of b minus f of a. F of b minus f of a. This is what, because of probability at a single point in case of continuous random variable is 0. Is this clear?
Yes,
Yes,
sir.
Yes,
sir.
sir.
So let me explain. Let me take some examples in for continuous random variables. Okay, any one of you. I want to. I would like to hear from you. So example for continuous random variable.
Time to reach school.
Time to reach school from home. Okay,
Yeah.
something like that. Okay.
Weights of people's weights, height, maybe.
Yeah. Weight or height, we can say, right? Weight or height of human being, or you can say of a person. Okay. What else?
Sir,
Yes, sir.
quantity of anything.
Temperature.
What do you mean by quantity?
Distance.
Distance, yeah, something distance from, you can say,
Yeah, distance of a plane from ground and
yeah, something distance, or you can say distance of, uh,
2 points
office,
between two
yeah,
points.
yeah, correct, of office from home or something like that. Okay.
How about people boarding a metro from a station? Is that discrete or
No,
continuous?
you want boarding to metro. You
From a
mean
station
with respect to time or with respect to?
with
Uh,
respect to time?
yeah, then it's continuous, right? So it may, okay. It
With
may be one
respect to
minute.
distance,
It may be 1 minute, one minute, some second. Okay. Suppose metro is coming within in an interval of 2 minutes, something like that. Okay. Then people can go from 0 to 2 minutes, right? In any values can be there, right?
No, no. I was
Huh.
saying the number of people.
Yeah. If you talk about
No,
number
it's
of people,
discrete.
then it's a discrete because you are counting, right? You are not measuring.
Oh,
I'm able to
it's
count, right?
countable.
Yeah.
Okay, yeah.
You count, right? 100 people went on that particular metro station at 9 a.m. Something like that, right? So you are counting. If you are able to count and it is taking distinct value on real number line, then it will become discrete. Okay?
Sure.
So speed of vehicle is what? It's a continuous, right? Because you have to measure, right? Yes or no?
Yes, sir. Yes, sir.
And what about this? I'm saying, let's say I'm saying time taken by student to complete an exam. Is it discrete or continuous?
Continuous.
Continuous, right?
Yes, sir.
Okay. Because suppose exam is of 3 hours, you can simply conclude. Okay. Now let's see what is the PDF? Anyone, any thought? If you've seen the lectures or something else, what's any thought on PDF? What do you understand by the PDF? Probability density function. Yeah, feel free to say. Don't worry whether it's a wrong
Sir,
or correct. It's fine.
integrated integral
No,
of
no, I don't
CDF.
want. I don't want formula. I need the idea behind PDF. Like, what do you mean by the PDF? What represents that probability density function?
Basically,
Area.
it represents the number of, like, for example, where the
Area under the curve.
maximum
Area under the curve. Sir.
Yeah, one by one. Yeah.
maximum occurrence of the random the variable that we are observing. So it would concentrate over at that level.
Okay. Any other thought?
Sir, summation of all the probabilities in a given interval.
Okay.
The collection of all the points making the area of that point.
Actually, sir, area under the curve.
Okay. Anybody? Anybody else?
Counting intervals.
Sorry?
Likelihood.
Yeah.
Counting intervals.
Yes, sir. Density.
What do you mean by counting intervals?
We have multiple intervals in the continuous one. So instead of having the example like a discrete where we can measure something, in continuous we don't have anything to measure. So if we had to find out the probability, it's better to identify the different intervals which can be integrated together to get the continuous probability.
Okay. Okay. Anybody? Any thought? Any other thought?
To get, sir, most
Likelihood, sir.
interval.
Can I?
Yeah.
It's the likelihood of any continuous random variable to take a particular value.
Okay.
Interval and any particular value. Interval.
Probability is
Sorry.
often like variables in an interval, not actually on a particular point.
Yes.
Okay. Okay. Yeah. Yeah. Some sort of is correct. Let me explain the. Okay. I will go with the then formal definition. Okay. Okay. You can see this white page, right?
Yes.
Yes, sir.
Yes, sir.
Okay. So let me define. Maybe I will draw some graph and all. Maybe that will give you the idea. So basically, continuous. I'm writing RV for random variable, continuous random variable with a CDF. Okay, we have seen transition from discrete CDF to continuous CDF. This is set to have a PDF. So full form of PDF is probability density function. Okay. Let's say we have to denote small f of x if for all small x. Okay. Don't worry about this kind of fancy terms. So suppose I'm saying fx of x naught is the one of the value. How will you calculate probability x less or equal to x naught? Okay, before this, you will tell me. So thing is, suppose I have some sort of function like this. Let's say some random function like this. Okay. Suppose this is function of your random variable. Okay. So thing is, suppose this is x naught. At this point, x naught. So question is probability x less or equal to x naught. That means what?
Left region of the.
Yeah, this part, right?
Yes.
I'm interested in the probability x less or equal to x naught.
Yes, sir.
And we know from the integration part, okay, what integration tells us? So integration just nothing but tells us the area under the curve, right? So this is something I can calculate.
sir.
Integration till what point? X naught. Okay, suppose lower limit is minus infinity.
Minus
So
infinity.
minus infinity is lower limit. So what is this? What we have to do? We have to simply integrate this function of x. Yes or no?
Yes, sir.
Okay, this part is okay. This part is clear to all of you.
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, so what is now this fx of x is nothing but probability density function. Okay, this is PDF. Okay, one more thing. Density is what? Density is what? What do you mean by density? Mass by volume. Correct me if I'm wrong.
Yes.
Right?
Yes, sir.
Here,
Yes, sir.
here what? Okay, this is similar to mass by area.
Yes, sir.
Right? So in case of in case of discrete, we are interested only in mass, right? We are interested only in weight of I mean, suppose I'm saying x is taking value x1, then what is the probability? What is the some sort of weight associated with that particular value? In case of continuous, we are not interested in mass. Rather than interested in mass, we are interested in mass by area. All right. So what is okay? Why we are doing okay? One more thing. In case of discrete, we are using the summation sign, right? But in case of continuous, we are using the integration sign. So this integration is nothing but continuous summation. Okay. So what is this continuous summation? Suppose I'm interested to find. Suppose this is, let's say, a minus delta, for example, and suppose this part is a plus delta. Okay. And my question is, suppose your random variable x will lie between a minus delta and a plus delta. Okay. For example, then what you have to do? You have to calculate the area, this area, right? Basically this area, dotted area, right?
Yes,
Yes,
sir.
no, right? So basically, we are using the integration. Okay, what we are doing in during integration, we are maybe those who have done mathematics, I mean, have studied mathematics in 11, 12 or something like that. So basically, you can say simply we have to make some rectangles, right? Some strips, yes or no? Some small, more large number of strips, right? This should be actually straight. Okay. So we have to make infinite number of, you can say, rectangles. Okay. And what we have to do to find the area under the curve, we have to add this continuous summation. We have to find this area of, basically you can say, what you have to do, we have to add the area of those rectangles. So how you can find? First of all, basically, whatever the functions you have to do, and there will be this. Okay, what this dx represents? I know I'm going in
Small
mathematics, but
value, small shift.
a small shift, right, for that random variable. Okay, so basically how you can calculate? It will be a minus delta to a plus delta. Okay, so you have to integrate that function with respect to x or whatever the function will be there within that particular region. So some sort of idea is okay about this continuous PDF and all. I mean, CDF and PDF. Yes, no? You got the idea?
Yes,
I'm
sir.
not,
Yes, sir.
okay. So this integration is nothing but integration is same as continuous summation. Okay, you have to do continuous summation. Basically, you have to add. I'm not going. It's a kind. So there is some history behind this Riemann integral and all. I'm not going into that depth. That's not important for us. The key thing I want to explain here, you have to do continuous summation to find the area under the curve. Okay. Is this clear?
Yes, sir.
Excuse me,
Yeah,
can
yes.
you show the definition part once?
Yeah, this part.
Oh, yes, sir.
All clear? So you can see, right? We have seen all these things, right? We have seen this part, which I have discussed in the first part. PMF of discrete random variable. We have seen CDF of discrete random variable. Then CDF of discrete random variable, we see whenever we are going to increase, and it will give you the CDF of continuous random variable. And from the CDF of continuous random variable, you can find the PDF of continuous random variable. So this picture is clear to all of you?
Yes, sir.
Okay. Okay.
So
So
the definition of PDF,
hmm.
I think, does that imply that the only way to actually derive a PDF, a unique PDF, is via the
No,
derivative
there
of
is okay, there is another definition also. Maybe if you are okay with mathematics, I'm not going to. Okay, let me explain. Maybe okay, do not ask the derivation part. Okay, because otherwise, okay. Suppose this is something, some function, something like that. Okay, suppose this is your f of x, for example. Okay, and I'm saying this is x. Okay, and suppose this is x plus, let's say this is dx. Okay, for example, dx, or you can say delta x. All right.
Yes, sir.
Okay. So okay, how you can find, if I will ask probability, your x will lie between small x to x plus dx.
So we have to integrate
I
the
forgot about
region.
integration. Okay, can I do like this? Yes or no?
Yes, sir.
So
That's
basically,
right.
another definition is something like that. If you want to define your f of x, means PDF of your random variable. So this is nothing but it's the probability your small x less or equal to capital X, x plus delta x, and divided by delta x, and this is something delta x to 0. Okay. So this is something a bit confusing. So you can go with this. Okay, a very simple definition. So this is CDF, and in CDF we have to we are integrating this f of x dx. So what is this f of x? This is nothing but PDF. If you have if you have been given the
I think,
PDF,
sir, I
yeah,
think
yeah,
summation will come over there, sir. Can you scroll down those?
where this one?
There's yes, sir. F of x dx, sir. Before that, summation will come, I think.
Summation sign. You mean this part?
Yes, sir.
Yeah, then you have to define the limit also then.
Okay.
Okay, so this basic definition is okay, right? So I just want to give you some basic idea. Okay, we are not.
Okay.
Yes, sir.
So in case of discrete random variable, right? So we have seen what are the basic properties for being a valid PMF. All the probabilities should be greater or equal to 0, as well
And
as
they are
summation of all the probabilities should be equal to 1,
one.
right? In case of PMF, right? First property is all the probabilities should be greater or equal to 0. Second is summation of all the probabilities should be equal to 1, right? If you have been given the PDF, so we will use basically, so what is the properties? First of all, f of x should be greater or equal to 0, right?
Yes, sir.
And we know here we can't use the summation. Since it's a continuous, so I will use the continuous summation. That means integral f of x dx should be equal to 1, and throughout the range, minus infinity to plus infinity means throughout the range. Yes or no? And one more property in case of PDF is f of x is actually piecewise continuous. So what do we mean by piecewise continuous? For example, I'm saying, suppose my PDF is given as something like that. Let's say x cube, let's say a1 less than x2, something, some another function, let's say x cube plus 2, something for some sort of range, and so on. So piecewise continuous means it should be continuous for this part, it should be continuous for this part and other parts. Okay, that is meaning of piecewise continuous. Okay, so far some rough picture is clear in your mind about continuous random variable. Yes, no? Okay.
Yes, sir.
So, okay, one more term in case of continuous random variable, that is called support of random variable. How will you define support of random variable?
Where the values are greater than 0.
So support of x is defined as nothing but values of x such that f of x should be greater than 0. That is something called support of x. Okay. So this support of x is nothing but it contains the intervals in which x can fall with positive probability. Idea is clear? So this support of X is nothing but contains the, you can say, kind of intervals, okay, in which your random variable X can fall with positive probability. Okay. Some sort of idea is okay? Yes, no?
Yes, sir.
Yes, sir.
Can you give an example, sir?
Yeah, support is okay. In case of discrete, okay, I will tell you. In case of discrete, we are using term range of your random variable, right?
Yes.
In case of continuous, you will use support of X. That's all. Okay. I will take one example. Don't worry. So suppose, okay, one more thing. Every one of you have pen and paper right now. If not,
Yes,
you
sir.
can take. Okay.
Yes, sir.
Because I would like to give some question and then you can solve so that it will be clear along with the session itself. Okay. Suppose I have f of x as, let's say, 4x cube, and support of x is 0 to 1, and it will take value 0, let's say. Otherwise, I have defined the PDF like this. So my question is, you have to check first part whether it's a valid PDF. Okay, before this, okay, can you tell me what is the support of X? It's a
The bracket of 0 and 1.
0 and 1, right? Because for this support, your probability will be, I mean, it will probability will be positive, right? That's the definition of support, right? All the
Yes,
values
sir.
of X when f of X is greater than 0. Yes or no?
Yes, sir.
So you can take any value, 0.5, 0.3, something, right? Fx will be greater than 0. So question is, you have to check whether it's a valid PDF. So what is the property for checking valid PDF? First of all, your all the probability, it should be greater or equal to 0. Yes. So
Yes.
this is true.
Yes, sir.
What is the second property?
Area
Integral over should be equal to 1, right? Yeah. So what? Okay, just I am giving you 1 minute and check and let me know. Or you want to do? I mean, if you are, I can do. Okay, let me do. Let me do first question, sir.
Sir, please explain the support of X thing again.
Yeah, support of X. Okay. So definition of support of X is nothing but all X values, collection of all X, you can say intervals, in which PDF will be greater than 0. That's all. I mean, with positive probability. That's all. Okay. So you can simply take support of X is what? 0 to 1, right? You can't, if you include 0, then what will be fx of 0? It will be 0, right? Support of X is nothing but all the collection of all the values of X where f of X is greater than 0. So if you take after 0, let's say 0.1. For 0.1, it will be greater than 0 or not?
Yes, sir.
Right? So that is the, okay. I will take some other examples also. So to check the valid PDF, we have to integrate throughout the range of X.
0 to 1.
Right?
Sorry to interrupt. One question back.
Yeah, sorry.
The 0, if you substitute 0 in the fx, it will create 0, right? So then the support will not be above 0. Is not 0 should not be included.
Yeah, that's why it's open bracket, right?
Okay, sure.
Yeah, okay. Now we have to check the integration throughout the range of X. It should be equal to 1. So now 4 I can take outside.
12x square.
So it will be 0 to 1 x cube dx. Okay. And what is the x raised power n dx? It's x raised power n plus 1 divided by n plus 1, right? By using this information, can I write x raised power 4 divided by 4, and range is 0 to 1. Now here you can see 4 will get cancel out and it will be 1 raised power 4. You have to substitute the upper limit. Okay, basically what? It's the remaining part, x raised power 4, 0 to 1. So you can substitute the values 1 raised power 4 minus 0 raised power 4, which is 1 minus 0, which is 1. So we can see area under the curve is 1. So it's a valid PDF. Yes or no?
Yes, sir.
Now, we have the information. Now it's a valid PDF, right? So it's a 4x cube, 0 to 1. It will take value 0 otherwise, right? So if I will ask probability that x less than half, how will you calculate?
Sir, integration 0 to half 4x cube dx.
So basically what okay, what we have to do, okay, what kind of graph of x cube look like?
Sir,
No idea.
Rising in
sir,
positive
how can I
and
say?
rise
It's
in
like
positive x
tangent graph.
and
Uh,
fall in left. Rise in right and fall in left.
It's like a tangent graph, like
Yeah.
tangent function graph.
okay, basically, okay, if you see about x cube only, right? So it
Yes,
will
sir.
be something like this and this, right?
Yes, sir.
So
Yes,
Yes.
sir.
since support is 0 to 1, right? So 0 to 1 I'm interested. So I'm interested only in the above part. Yes or no?
Yes, sir.
Yes, sir.
So what you have to do, I'm asking x less than half. So suppose half is there. Suppose half is here. Okay. Okay. Just assume half is. So what you have to do to calculate this area, right?
Yes, sir. 0 to half
Yes, sir.
Correct. 0 to
4x
half.
cube
So what you have
dx.
to do, you have to integrate from 0 to half.
0 to
And we
half
have seen
4x cube dx.
we have seen if I'm interested to calculate area. Okay. Let's say this is suppose 0 and this is half. Okay. Suppose this is 1, for example, and I have to calculate this part, right? So what I will do, I will integrate from 0 to half, right?
Half. Yes,
So
sir.
we have to do 0 to half. Why 0? Because lower limit is 0. What we
0
have to do, integrate 4x cube dx.
dx.
Yes or no? Everyone
The
is
rest
getting this.
part is. Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So this just same thing we have to do. So again, x cube dx 0 to half, and it will be 4 into x raised power 4 divided by 4, and limits will be 0 to.
So the answer will be 1 by 16, I
So it
guess.
will be x raised power 4 0 to half. Yeah. So it will be 1 upon 2 raised power 4 minus 0. So it's a 1 by 16. Okay. If this is clear, so I'm going to give you 2 minutes and solve this problem. 1 by 4 less than x less than 3 by 4 using the same PDF. I mean, so f of x is 4x cube, region is 0 to 1. It will take value 0 otherwise. Okay. So you are 2 to 3 minutes. Okay. Subhankar, can you please mute? There is background noise from. Yeah. Thank you. So I'm going to give you some 2 to 3 minutes. Okay, solve this question.
Sir, 80 by 256.
Yes, I will see.
Yeah, so everyone got the answer or
Yes, sir.
Yes,
80
sir.
by 256.
80 or 56?
Yes,
Let's see. Don't worry. Okay, so what we have to do basically, main region is 0 to 1, right? So basically, suppose this is 0, and for example, suppose this is 1. Okay, this is 1, right? That is something graph, right? You have to calculate 1 by 4 area between, let's say this is 1 by 4, suppose this is 3 by 4. So you have to calculate this part, right? Yes or no? So
Yes, sir.
we have to integrate from 1 by 4 to 3 by 4, and we have PDF, right? So 4 I can take outside, and x cube of dx 1 by 4 up to 3 by 4. So it will be x4 divided by 4. Everyone is getting this point, right? X by 4 and divided by 4, whatever I'm writing. It will be 1 by 4. If you are not getting, let me know. So 4 will get cancel out. So it's x raised power 4, 3 by 4 and 1 by 4. So it will be 3 by 4 raised power 4 minus 1 by 4 raised power 4. So 4 raised power 4, I think it's
256.
256, right? Yeah, correct. So 256 and 3 raised power 4 is 87 minus 1.
So 81.
Sorry, 81 minus 1. So it will be 80 divided by 256, the correct answer. Okay. What if I will ask, suppose, okay, so I'm just trying to give you the flavor for, each different types of question. Actually, I will ask probability x less than half, given that x less than 3 by 4. How will you proceed? What will be the numerator part?
Sir, the recent one and the denominator part will be the previous to previous one.
Okay, forget. Okay, first of all, let's try to do like this. If you have been given probability A given B, right? Conditional probability. Then how will you proceed? Probability of A intersection B divided by probability of B.
Yes, sir.
Right? Yes. And I'm okay. How will you calculate this part? So this will be, if you have been given probability x less than half, given that x is less than 3 by 4. So that means I have to write probability x less than half and x less than 3 by 4 divided by probability x less than 3 by 4. Okay. By this, is it clear how to write like this?
Yes,
So
sir.
the key thing, we have to find the numerator part. Okay. So how we can calculate? So what is the total limit? Total limit is 0 to 1. Okay. And suppose this is half, and for example, suppose this is 3 by 4. So x less than half means this green part. Yes or no? And
Yes.
x less than 3 by 4 means this red part. And we have to find the common area between these two. So what is the common part?
Green
Green
part.
Basically, I can say, yeah, this blue part, right? Yes or no?
Yes,
This is
sir.
the common part, right? So that means what? What is this common part?
X is
Probability
less
X
than
less
half.
than half divided by probability x less than.
3 by 4.
Now you can see how simple it is, right? So,
Yes,
and
sir.
we have calculated probability x less than half as 1 by 16, right? So it will be 1 by 16, and you have to calculate probability x less than 3 by 4. So whatever the values you will get, just divide by this, you will get the final answer.
81 by 256.
81 divided by 256 for
Yes,
this.
sir.
Okay, I'm assuming it's a correct. Okay.
Yeah.
No, it's fine. How you can see how to calculate these kind of values? Yes or no?
Yes, sir. Yes, sir.
Yes, sir, clear.
Okay. Now let me write one more. Now this question you people will do. Okay. Similar sort of. Suppose I'm saying I have been given. Suppose I have been given f of x as, let's say I'm saying it's k 4x minus 2x square, and x is 0 to 2, and it will take value 0 otherwise. So my question is, first question is, what is the value of k? Okay. Second question is, you have to calculate probability x greater than 1. So how will you proceed for the first question?
We can
Sir, integrate is equal to 1 if we do those like another answer.
So, okay, correct. So, we know the properties of being a valid PDF. First of all, probability should be greater or equal to 0. Second is area under the curve, means integration throughout the range, support of X should be equal to 1, right? So, by using that information, you can calculate the value of K, yes or no?
Yes, sir, it is very easy.
Okay. So, everyone please calculate and let me know what is the answer.
What 3/8?
Yes, sir. 3.
Yes, sir, 3/8 answer.
So I got the response only from 3 people. So others are trying, or you are just simply waiting for me to solve the question?
No, it's 3/8.
Sir, you should not solve it, sir. It is very easy.
Okay, 0.375. Okay. So if you are still trying, I can wait. Okay, that's not a problem.
No, sir. Proceed.
Okay, let's try to solve the question. Okay, let me, because suppose those who haven't done. So this is PDF is given to us. So we know the property area under the curve. I mean, from minus infinity to plus infinity means total area. I mean, total support of, support of your X. This should be equal to 1. And we have been given the support of X as a 2, 0 to 2, and K. And what is the f of X? 4X minus 2x square dx. This should be equal to 1. That is information, and by using this information we will calculate the value of K, right? So K I can take outside because it's a constant, and what I can do, rest I can do as a 0 to 2 4x dx minus 0 to 2 2x square dx. Everyone is okay with this?
Yes.
Right? Okay. So K and 4x. So if you will do integration of x, it will be x square by 2 minus 2 times x cube divided by 3, 0 to 2. Yes or no? So we have to put the upper limit. So if you substitute 2, you will get 4 by 2 and 2 raised to power 2, which is into 4 minus 2 by 3, 2 raised to power 3, which is 8, and minus of 0. So once you will put 0, this will be 0 minus 0. It will give you 0. And here you will get 16 by 2 minus 16 by 3 equal to 1. And it's basically 8 minus. So if you solve this, it will be K times 8 minus 16 by 3 equal to 1. So it will be K into, so 24 minus 16. Yes or no?
Yes, sir.
So 24 minus 16 is what? 8.
8 by
8
3.
by 3 equal to 1. And from here, K will be 3 by 8. Okay, so 3 by 8, the 8 is the correct answer. What about probability X greater than 1? Okay, so
Half.
okay, so that is something you can do with intuition also, but let's try to understand the formula itself. So we got 3 by 8 and we have the PDF as 4x minus 2x square, right? 0 to 2. Yes or no? Yeah, here initially in the
Yes,
place
sir.
at the
Yes,
place
sir.
of
Yes, sir.
3 we had k. Now it's a 3. So probability x greater than 1 means what? I have to
One.
integrate 1 to 2,
1 to 2.
Yes, sir.
right?
Yes, sir.
Yes, sir.
Because upper limit, okay, probability x greater than 1. So basically you can see x is taking value onwards 1, right? But what is the upper limit? Upper limit is only 2. It will be 3 by 8 and
2.
4x minus 2x square dx. So whenever you will solve, once you will solve, you will get the half. Half is the correct answer for this.
Yes, sir.
You know.
Yes, sir.
Okay. One more question.
Sir, these things have been discussed in statistics 1 course, isn't it?
Yeah. I also think so.
Okay,
Yes.
so statistics 2 is the one step ahead the statistics 1. Okay.
Yes.
Okay, so we need to see the bridge. Okay. Don't worry.
Okay, okay.
Once you will move on week 5, week 6 onwards, you will see the importance of these kind of things. Okay.
Week 1 to week 4 of statistics 2 is basically revision of the stats only.
Okay, let me give you one more fx PDF. So let me take another example. Suppose fx is some sort of
Sir,
like this, x by 4. Yeah, 1 minute. X is lies between -1 to 3 and it is taking value 0. Now tell me, this is valid PDF or not?
No, sir.
Why?
Because, sir, for -1, this will be negative. Function will be negative.
But okay, so if you integrate -1 to 3, this x by 4 dx, I think you will get value 1. You can cross check.
Yes, sir.
Right?
yes, sir.
I will
So
check.
but one property is fulfilled, but first property should be greater or equal to 0 is not fulfilled, right?
Yes, sir.
Because for -1, probability is not greater or equal to 0.
For
So
the
this is not a
interval of
correct.
-1 to
This
0.
is this is not a valid PDF. Okay, so
Yes,
you have to
sir.
make sure about these contents. Yeah, someone was asking some question. Yeah, please go ahead.
Sir, the moment when you said that you can do it by intuition also, when the question was probability of x is greater than 1. So is it necessary when we have a midpoint of two intervals, it is always equal to 0.5?
No, actually intuition I means first you can simply draw the graph of that by you. Okay, have you heard about Desmos or something like that? Desmos, some graphic calculator.
Yes, sir.
So if you draw there, right, you will get some sort of idea. That's what I mean by intuition. Okay. Otherwise, it good to go with the formula. Okay.
Okay.
Yeah.
Got it.
Yeah. Someone was asking some other question. I think I stopped.
Sir,
Yeah.
I could not understand this. How did you got this 1 by 2? The probability x is
This
greater
one.
than. Yes, sir.
Okay. Let's solve this. I think solution is the more important. Okay.
Sir,
First
please
of all,
the previous question, sir.
yeah. This one.
Yes, sir.
Huh?
Sir, some little bits.
Okay. Any doubt?
Okay, sir.
Clear?
No. Just no, sir, no doubt.
Okay. So first of all, this part is clear. This defining 1 to 2, right?
Yes, sir.
3 by
It's clear.
8 and it's 4x minus 2x square dx. Okay. Now let's solve this. Okay. First of all, 3 by 8. Okay. What you will get? 1 to 2. I can do 4x dx minus 1 to 2, 2x square dx. Yes? No?
Yes, sir. Yes,
Right?
sir.
So if you can see this part 3 by 8, so 4 x dx 1 to 2 minus 2 x square dx 1 to 2.
Yes, sir.
Right? And we know the integration x raised power n dx is nothing but x raised power n plus 1 divided by n plus 1. So by
Sir,
using,
got it. Actually, it's basic integration. Yeah, got it.
correct? So it will be
Yes.
4 into x square by 2 minus 2 into x cube by 3, 0 to 1, 0 to 1. Sorry, 1 to 2, 1 to 2. So what you have to do now, you have to substitute the upper limit minus lower. So it will become 2x square 1 to 2 minus it will be 2 by 3 x cube 1 to 2, right? So now what you will get from here, 3 by 8. So you have to substitute the upper limit, right? So it will be 2 raised power 2. Basically what you have to do, 2 raised power 2 minus 1 square, this lower limit, minus 2 by 3, 2 raised power cube minus 1 cube. All right? Yes? No?
Yes, sir. Yes, sir.
Yes,
Okay.
sir.
So it will be 2, 4 minus 1, which is
Into
3,
3.
minus, it will be 8 minus 1, which
7,
is
7.
7. So it will be 3 by 8, 6 minus 14 divided by 3, right?
So that
So
would be 4 by 3.
4 by 3?
4 by 3.
6 into 3, 18 minus 14, 4 by 3.
Yeah, that is 4 by 3. Yeah. So 3 by 8 into 4 by 3, which is nothing but 3 will get cancelled out half. Okay. So, okay, if you don't want to draw the graph and all, suppose during the examination you can't access the, you know,
Desmos.
Desmos
Yes,
and all,
sir.
then it's good to go with this formula and all, basic formula. Okay. So, okay, first of all, this idea is okay. Will you able to solve the questions of
Yes, sir. Yes, sir. The idea is
week
okay, sir.
4?
Yes, sir.
Okay.
Yes,
I
sir.
think I have covered more or less every kind of questions, right? How to find the constant and all, and
Yes,
you know,
sir.
piecewise
Sir, yes,
continuous
sir.
and all. Okay.
All, all the basic
So can
concepts
we
are
see
clear.
the last question we did again? The last no,
This part?
no, scroll down all the way down. No, that is up. Scroll down.
Yeah, that's all, right? That's all we did.
Oh, that's the latest one. So do you remember that example where because it was negative, so it was not a valid PDF?
Correct.
Yeah, I don't understand that.
Yes, sir. How do you know? Do we know that that would be negative?
Okay. So what is the support of this?
Yeah, so it's
-1 and 3.
Right. If you substitute -1 for this part, what you will get?
-1 by 4.
Right. That shouldn't be there, right?
Yes. Okay, sir.
Clear?
Clear.
Okay. Yeah. Even if you solve this, right? I took this example with intention. If you solve this integration part, right, you will get 1 by total area 1. Because what we are doing, sometimes we didn't focus on the first part, means f of x should be greater or equal to 0. We simply integrate. Suppose I ask some PDF is given to you and ask check whether it's a valid PDF or not. So what people does, they simply integrate over the support of x and they find, yeah, it's 1, but they simply say answer is yes. But no, you need to check this part also. Okay, for that particular support, if you will solve this 1 by 4 x dx, it will be x square by 2, it will be -1 to 3, so it will be 1 by 8. So 3 square minus -1 square, so it's 1 by 8. 9 minus 1, which is 8 by 8, which is 1, right? But thing is that this f of x is not greater or equal to 0. Okay, for this support. Yes or no?
Yes, sir.
Okay?
Yes,
That's
sir.
why it's not a valid PDF.
Yes, sir.
Clear?
It violates the first condition.
First condition, correct. Okay. Do you want to solve some other question?
Yes, sir. Please give.
Okay. Let me give you one more question. Maybe you
Sir,
can.
if the concepts means if the we have next session for Python 8.
When 8.
8. Yeah.
Okay.
If the
Then
concept are not
actually we are done with the concept. I'm just I will
okay.
give some more question to give you whether you are able to solve the questions or not. Yes, Pyari. Do you have any query?
Yeah, I was just going through the videos, and I think I
Uh-huh.
have not finished the last one. And you have also not covered that part, I
Last
think.
one is what?
Common distributions.
Sorry?
Common distributions. There is one more set of videos, right? Which says common distributions.
Common distribution. One more thing. One second.
It has that binomial exponential functions and all that.
Yeah, 1 minute. Let me check. Sir has discussed in the common distribution. Okay. Got it. So some distributions. Okay, this kind of questions you will be able to do, right? Okay, understood. Okay, sir has taken the I took the some basic PDF. Sir has discussed with the. Okay. Let me explain. Don't worry. Okay, let me explain. Got the idea. So in this last lecture, sir took okay, I took some basic definition. I mean PDF, right? Some random PDF, probability density function, right? So sir took the PDF of the continuous distribution. Suppose I'm saying first one X follows continuous uniform distribution for the range A to B. Okay. Then what is the PDF in case of uniform distribution? We have done stats 1 course already. Anyone can remember?
1 by A plus B.
Sir, 1 by A minus B.
1 upon B minus A.
B minus A. Yes.
Right.
Yes.
And support of X is A to B. And it will take value 0 otherwise. Okay. So
Yes, sir.
you can even you can cross verify this part. Okay.
So we have to just integrate over A to B.
Basically,
sir.
what you have to do, suppose this is A, this is B, right? Okay. Suppose this is K. And okay, what is the meaning of this part? Your X will take uniformly same value for this particular region, right? How you can calculate
Yes,
this
sir.
part? Okay.
Sir, integration over A to B.
Yeah.
K into dx.
K into dx, right? If you solve that, you will get this part. Okay. Okay. That is something is there in case of uniform. And what about okay? Suppose f x of x. So how will you proceed with this? Means what do you mean by this? Probability x less or equal to small x?
Yeah.
Yes.
Yeah, that is the meaning of CDF, right? This capital f of x will represent the CDF of your x, right? So this means probability x less or equal to x. Okay. If in this case, what is the okay. If you want to find the area, suppose this is x. I want to calculate this area. Okay. Yes or no? Then what I can do?
Yes, sir.
I can integrate a to x 1 upon b minus a dx or not?
Yeah.
Yes or no? What is this? This is
Yes, sir.
PDF of your uniform distribution. And 1 upon b minus a, I can take outside. It will be a to x 1 into dx.
Yes, sir.
And it will be 1 upon b minus a. If you integrate 1 dx, it will give you x a. So this is small x is nothing but one of the, you can say, value. So it will be 1 upon b minus a into
X
upper
minus
limit
A.
minus lower limit. So what is the CDF of uniform distribution? X minus a divided by b minus a. So the same thing you can do. Actually, you can see if you have the formula, CDF formula in your mind, you can directly use without using the integration. In case of this
Yes, sir.
uniform, I mean, in case of standard distribution. All right. Yes or no? So
Yes, sir.
okay.
Yes, sir.
Okay, why this is useful? Suppose I ask what is the probability that 1 by x will lie between 1 by 4 and 3 by 4. So there is two ways. One way is you can integrate 1 by 4 to, okay, what will be
3
the
by
PDF?
4.
Okay, first of all, what will the PDF for this?
1 by b minus a.
Sorry? Yeah,
1 by b
PDF
minus
is
a.
1. Okay.
No.
Okay. Suppose I'm saying x follows uniform 0, 1. Okay. In this case, PDF is what? 1 upon 1 minus 0, which is 1, right?
1.
If I
Yes,
want
sir.
to calculate this part, what I have to do? I have to integrate 1 by 4 to 3 by 4 fx.
1 into dx.
Right. So I have to integrate 1 by 4 to 3 by 4, 1 into dx.
Yes, sir.
Sir,
That
you
is
should
something I have to
put
integrate,
your
right?
laptop on charge.
So what
Yes,
it will
sir.
I
be?
think
Sorry?
From where are we
sir,
getting 1?
you should put your laptop on charge. I
Yeah,
think
thanks for the reminder. Yeah, so here I'm saying x follows uniform 0, 1. That's why I'm getting 1. Okay?
Yes, sir.
Yes? No? Is it
Yes.
clear? So if you
So I'm not
integrate
getting
one, yeah, sorry?
I'm not getting it, sir.
This part.
Yes.
Okay, what is the PDF of uniform distribution? If I'm saying X is follows uniform A comma B, then PDF is 1
1
upon
by
B
B
minus A.
minus A.
If
Yeah.
I'm saying X follows uniform 0 comma 1, then what will the PDF? 1 upon 1 minus 0, which is 1 by 1, which is 1,
Okay, okay, sir. Yes,
right?
yes, yes.
Now, so what is the value here? You will get 3 by 4 minus 1 by 4, right? Which is 1 by 2. Yes or no? This is with
Yes.
the help of integration. Suppose you don't know integration, but you know this CDF form. Okay, and I have we have seen this formula, probability a1 by 4 less than x less than 3 by 4. Okay, you can recall this formula, right? Probability a less than x less than b is nothing but what? Fx of b minus fx of a. Yes or no? So from here, can I write fx of 3 by 4 minus fx of 1 by 4? Yes, no?
Yes.
I heard only one yes. That means
Yes,
others
sir.
are not getting.
Yes,
Right?
sir.
Are you getting this part, right? This formula we have seen already.
Yes, sir.
Can you recall this part, right? So we know what is the CDF of uniform distribution? Fx of x is nothing but x minus a divided by
B
b
minus A.
minus a. So what I can write? What is small x here? 3 by 4. Value of a is 0, right? For this particular case. Yes or no? Divide by
Yes.
b
Yes, sir.
minus a, which is nothing but 1 minus 0
Yes, sir.
minus 1 by 4 minus 0 divided by 1
1
minus
minus
0.
0.
Again, you can see you got 3 by 4 minus 1 by 4, which is half.
Half.
Right. So you can see with this importance of that formula. I mean, this kind of all this formula which we have discussed earlier. Where it went? All this formula, right? You can see importance of all this formula. Yes or no? In case of continuous, you can simply write this f of b, f of a, f of b,
Yes,
f
sir.
of a, f of b, f of a, f of b, f of a. Right?
Yes, sir.
Clear?
Yes, sir.
Okay. So yeah, so similarly you can do for other distribution also, right? So you can do for exponential, okay, you can do for other continuous distribution also.
Sir, how can we get a CDF from a PDF?
CDF from a PDF. Okay.
Yes, sir.
So okay, suppose what is f of x is this?
Sir, there is a question in activity 4.58.
Yeah, one
question.
second, one second. What this represent?
This represent a CDF?
This is CDF, right? You are asking CDF
Yes.
from a PDF.
Yes, sir.
Yeah. So if you have been given the PDF, you can calculate the CDF.
How, sir?
Yeah, this is the PDF, right?
Oh, okay, okay. So we have to
Okay, I think you
integrate.
are asking if you have been given CDF, how you can calculate the PDF. Okay.
No, no, sir. PDF to CDF. We have given a PDF. How can we get a CDF?
Yeah, this is PDF. You can simply
Yes, sir.
integrate. You can find.
Okay. Oh, okay,
Okay.
okay.
If you want to calculate PDF from a CDF, then you have to do this part,
Differentiate.
differences. Okay.
Yes, sir. Yes, sir. For getting CDF from a PDF, we have to integrate, and if from getting PDF, no, sorry, CDF.
See. Don't memorize, blindly. Okay.
Oh, okay,
One more
sir.
thing, just keep in your mind, f of x is nothing but probability x less or equal to x. This is something area under the curve till x. You have to integrate minus infinity to x fx dx. So this is PDF and this is CDF. That's all. Okay. Do not
Okay.
memorize just integration and all. And you want to do reverse order, then f of x will be nothing but d of dx f of x. So just keep in mind these things. Other thing you can get automatically. Okay.
Got it. Got it, sir.
Okay. So I think Pyari Singh asked this, or somebody else asked this common distribution, right?
Yeah,
Correct.
yeah. So
Yeah.
are
No.
you are you are
Yeah.
you saying we don't have to specifically try out different distributions? We can take the
Actually,
general approach?
correct. Actually, I took the general approach. You can see in the lecture, sir took initially, then sir had taken the normal, right?
Yeah.
Okay, I will take. Okay, normal is at the end. I will tell you the okay, you can simply do for exponential also, right? Can you see my screen, right?
Yeah.
The key thing is, if you have the PDF, right, f of x, it can be anything. It can be for a PDF of a standard distribution. Okay. Okay. Let me take some this exponential and normal also. Okay. So suppose I'm saying x follows exponential with parameter lambda. What is the PDF? Lambda into e raised power minus lambda x, and support is x is greater or equal to 0, and it will take value 0. Otherwise, yes or no, this is PDF, right?
Yes, sir.
Yes, sir.
If I will ask f of x means CDF means probability x less or equal to x, then what you have to do? You have to integrate 0 to small x lambda e raised power minus lambda x dx. Yes or no?
Yes, sir.
So once you will solve this, I'm not going to do the derivation. You will get e raised power minus lambda x. Actually, this is the CDF of your exponential distribution. Okay. Now, in this case, suppose I ask what is the probability x is lies between 1 to 2. Then what you will do? I have to integrate 1 to 2. Okay, basic definition. How will you find this probability x is lies between 1 to 2? You have to find the area 1 to 2. I mean, basically, you have to integrate 1 to 2 fx dx. Right, in general.
Yes, sir.
Right, and
Yes, sir.
now we know what is the fx dx. Lambda e raised power minus
E
lambda
to the
x
power minus
dx.
lambda x.
Basically,
dx.
there will be some values for lambda 4, 3, 1 by 5, anything, right? There will be some value. I'm just trying to explain in general. Okay, this is something. Or else, what you can do? Suppose lambda is 3, for example. Okay. This is one approach. Another approach is you can use directly this CDF. Okay. Means if you have been given 1 less than x less than 2, how you can calculate? Can I write fx of 2 minus fx of 1? Yes or no?
Yes, sir.
Right? Would you agree with me? This formula? Everyone is
Yes,
getting?
sir. Yes, sir.
And
Yes, sir.
we know what is the fx of x in case of exponential?
Sir, 1
1
minus e to the power minus lambda x.
1 minus e raised power minus lambda x minus 1 minus e raised power minus lambda. Instead of x, we have 2 here, right? And here 1.
And in case here it will be 1.
Everyone is getting?
Yes, sir.
Yes, no? So you
So
can
this
see
is
1
just a
minus,
direct formula.
yeah, this is direct formula. 1 minus e raised power minus 2 lambda minus 1 plus e raised power minus lambda. So you can see you got e raised power minus lambda.
If
Yeah,
we
1
don't
minute.
use the
1 minute. If I'm explaining something, let me complete. Okay. So you can see we got this formula, right? I mean this equation. E raised power minus lambda minus e raised power minus 2 lambda. The same thing you will get once you will derive this. I mean solve this equation.
Okay.
So you can see the importance of CDF. If you know the your x is following some standard distribution, and if you know the formula of CDF, then you can without doing the integration part you can do. Even using the integration you can do. Do you want to solve this one? I can solve this. Yes, no?
Yes, let's do it, sir.
Okay, let's do it. Okay, let's do it. So 1 to 2 you have to integrate, right? This is the basic definition, right? And what is the PDF here? Lambda e raised power minus lambda x dx. All right. So lambda I can take outside because it's a constant. So 1 to 2 e raised power minus lambda x dx. So one thing maybe so integration of e raised power ax dx is nothing but e raised power ax divided by a, whatever the
a
constant
plus
is.
c.
Right? Now here you have e raised power minus lambda x and denominator will be minus lambda. So suppose a as a minus lambda 1 to 2. We have to substitute the value. So lambda will get cancelled out, right? Minus is there and we have to put the upper limit. I mean this 2. It will be minus lambda into 2 minus e raised power minus lambda into 1. Clear?
Yeah.
Yes.
So we got e raised power minus 2 lambda. This minus will be plus e raised power minus lambda. We got e raised power minus lambda, e raised power minus 2 lambda, which is same as this part
On the CDF.
Correct. So if you know the integration part, right? So you can directly do, or else if you know the CDF formula, you can go with that also. So in both way you will get the same
answer. Yes.
Clear?
Yes, sir.
Yes, sir.
Pyari, is it okay
Yes,
now?
yes. Yes, sir.
Okay.
Yes, sir.
another thing is in case of normal distribution actually. So, okay, how many of you can recall the normal distribution from stats 1 content? No? Okay, let me give you a quick idea.
Yes, sir.
Suppose I'm saying X follows normal distribution, the way we are right as with parameter mu, comma, sigma square. This is mean and this is variance of your X. Okay. And basically this expectation of X is mu here and variance of X is here sigma square, right? And what is the PDF of normal distribution actually? It's 1 upon sigma root 2 pi e raised power minus 1 by 2 sigma square x minus mu whole square. This is the PDF of normal distribution. And support of normal distribution is minus infinity to infinity. One more thing, why we are moving to the standard normal variable actually.
Sir, sigma will be in under root, right?
No, it's
No,
correct.
no.
It's correct.
It's
Okay,
correct.
right? It's correct. So what is the CDF? How will define? So probability x less or equal to x, right? In this case, if you integrate minus infinity to x, this part, right? 1 upon sigma root 2 pi e raised power minus 1 by 2 sigma square x minus mu square dx. So this is not an easy thing. Yes or no? You will not get a kind of closed form of this CDF actually. Okay. So because of that, in case of normal distribution, we are moving, that is very, very important, called standard normal distribution. Okay. So what is the standard normal distribution? If axis follows normal mu comma sigma square, this is with mean mu and variance sigma square, it will be in standard normal distribution when if you say x follows normal with mean 0 and variance 1, then you will say this is the standard normal distribution. Okay. Or else you can say, suppose, let's say
Z
there is
is
one
x
z, yeah,
minus mu by
z. Okay.
sigma.
So how we can find this part actually? So this is called the z is your nothing but standard normal variable. Okay. So how I can find this standard normal? Suppose whatever I'm saying x follows normal mu comma sigma square. Okay. Then z is defined as x minus mu divided by sigma will follow normal 0 comma 1. So this mu is nothing but expected value of x. Sigma is nothing but standard deviation of x. We can cross check. Okay, is this okay, or do you want to me cross check how we are getting this mean 0 and 1?
No.
This is fine, sir.
This is fine, right? You know how to calculate expectation of z, right? If you calculate expectation of z, expectation of x is mu minus mu, which is 0, right?
Yes.
Basically, it will be
Yeah,
like this,
it is
right?
standardized.
So mu minus mu divided by sigma, which is 0, right? If you calculate variance of z, it will be variance of x minus mu divided by sigma, which is nothing but 1 upon sigma square, variance of x minus mu. And there is no effect of adding or subtracting a constant. It will be variance of x divided by sigma square divided by sigma square, which is 1. So you can see this is part. Okay. So this is standard normal variable. Actually, what is the graph look like for a normal distribution? It's a sorry, I'm not able to draw it properly here, but it's a bell-shaped curve. Okay, it's a bell-shaped curve, and peak is at mu. Okay, mean at mu means suppose this is mu. Mu is 0. I have drawn for standard normal variable actually. So what is the importance this? Suppose I will ask probability z less or equal to 0. Then what is this?
Left side.
Left side, right? This means probability half, and probability z greater than 0 is 0.5, right? Because it's a symmetric curve actually. If you will flip this part to this part, it will cover. It's kind of, you can say, mirror image. Okay. So why we are moving this standard normal and all whatever the things I have discussed so far? Actually, we do not have, it's very difficult to calculate this CDF part, right? In case of exponential and all, we have seen we are able to integrate, right? In case of uniform also, but in case of normal, we can't. So we are moving to the something called standard normal variable, and for that maybe you can Google and you will get. It's called standard normal table. Okay. So from there, you can calculate the values. What do I mean with calculate the values? Suppose I'm saying x follows normal with mean with mean 2 and variance is 25. For example, this is one of the example. And I ask what is the value probability x less than 5. So what is one way? One way is you can integrate minus infinity to 5 1 upon sigma root 2 pi e raised power minus 1 by 2 sigma square x minus mu whole square dx, right? This is one way.
Yeah.
Okay? Which is very, very, very difficult. Kind of, you can say you can't get a closed form, right? Another way is you know how to convert this in standard normal variable. How I can convert? I have to subtract mu divide by sigma, yes or no? And I can do 5 minus mu is 2. What will be sigma? Again?
5.
5. So what you will get from here? This is nothing but g less than 3 by
5.
So probability g less than 0.6. So this value in exam, normally if this kind of question, you will get the values, or else you can, I mean, in general, you can Google it and you can simply find the probability z less than 0.6. Okay, from the table you can easily calculate. Okay, suppose I'm saying probability x less than 2. That means what? X minus 2 divided by sigma. I mean, let the x minus mu divided by sigma less than 2 minus mu divided by sigma. So probability, this is nothing but this will become g less than mu is 2, right?
Yes,
2
sir.
minus 2 divided by 5.
Yes,
So
sir.
we got probability g less than 0.
0.
This is 0.5. No need of table, right? Because see, this is mu is see, z is what? Standard normal table, right? We know standard normal table is base shaped curve. So this is half, right? Probability z less than 0. It's a symmetric curve.
Yeah.
Symmetric curve means suppose you have any point minus a here and another point a is here. So probability this part and probability I mean probability z less than minus a. This is same as probability z greater or equal to a. Okay. Understood?
Yeah.
Yes, sir.
Okay. Okay, this is something you can see simply here exponential is given to us, right? Now let me take one example if that is okay. Yeah, suppose this is x follow normal 2 comma 5. Okay, if I've been asked probability x less than 5, then what you can do? X follows normal 2 comma 5. Question is probability x less than 2. Okay, so I can convert it in standard normal variable. It will be x minus mu divided by sigma less than 2 minus mu divided by sigma. So this will become z, right? So z less than 2 minus mu is 2.
2.
Okay,
Root 5.
it's a 5. Okay, it's again 0. It's again 0.5. So it's a probability x less than 5, right? So what is this case? X minus mu divided by sigma less than 5 minus mu divided by sigma, right? So this will become z less than 5 minus
3 by 5.
2. No, not 5, right?
Root 5. Root 5.
Root 5. Okay, because here variance is 5, right?
Yes, sir.
Okay, so it will be probability z less than or equal to 3 by root 5, and you can simply see the abject table. Okay, basically you can you can search on Google abject table. Not sorry, it's so you can see these values, right? So this left hand side it represents, so if you have minus 3.0 only, means if I will ask probability z less than minus 3.0, so you can see the first part, right? So this part, this will give you my 0.0013 value for probability z less than minus. One more thing, this table is always for less than case. It's called abject table. Abject means probability z less or equal to some value. Okay, if you have been given the value z greater than, let's say 2, then you have to first 1 minus probability z less or equal to 2. then calculate this value and substitute here. Okay, got it?
Okay, sir, got it.
So basically, let me show here. Suppose I'm saying 1.0. For example, suppose you got probability z less than 1.0. So for 1.0, this is 1.0, and this is for other decimal points, other decimal places. So it's a 0.8413. Okay. If I will ask probability z less than 1.3, how you can see the values? So this is 1 point, this is 3. So this value 0.8485 will be correct value. Got it?
Yes, sir.
Is this clear, right? Pyari and all. I mean, this is okay.
Yeah, that part I think that when you started an example, could you just repeat once again, sir? Or maybe I just
this one?
No. That is all fine. You just took an example, right? Last towards
For
the
the
end.
table, sir. I think for the table.
Yeah.
For the table. Okay.
Yeah.
Okay. Yeah.
It is 1.03.
Less than 1. How did you calculate that?
This one? I just took randomly.
Okay. Now, how did
Yeah,
you?
yeah. Okay.
Actually, I just wanted to show how to see the values from table. That's
Yeah,
what I
that
want.
is actually what I didn't get. How did you interpret the table?
Okay, so this you can see this left hand side, right? This column. Okay.
Yeah.
So suppose 1.0 is there. So this is another places after decimal. Okay. If you have 1.1, so 1.1.
No,
Okay.
sir. 1.1 will be
Sorry,
down.
1.0.
1.01.
1.01. Sorry,
Yeah.
1.01. Oh, 1 second. So 1.3. This is wrong actually. Correct. So for probability 1.3, you can see this is 1.3, right? And after
Yes.
3, there is no decimal. So 0.9032 value will be 0. Okay. If I will ask probability z less than 1.31, so you can see this is 1.3 and this is 1, right? So 1.3 after 3, 1. So 0.9049. Got it?
Correct. Yeah.
If 1 point, suppose 5, 3, so 1.5, this is 3.
Right.
So this is 3. You can see, can you see this cursor point, right?
Yes.
Okay. This is something you have to see in front. One more thing, just keep in mind, this is the this table always about fz. Okay. That's why it's a less than. Suppose in the question, in any question which has been asked, probability z, I mean, you got probability z greater than 1.31, then what you have to do? 1 minus probability z less than or equal to 1.31. Whatever the values is there, 1 minus, subtract this value, you will get the answer for this. Got it?
Got it.
Yes.
Okay. Yeah. So I think that's all from my side for this particular. I think.
Sir, are we gonna get all the PDFs and CDF formulas in the exams?
Yeah. You will get the PDF. If all distributions and expectation variance and I mean CDF, PDF,
Sir,
everything
I
you will
have a
get.
doubt.
The one thing you have to apply the concept. Yes.
Sir, if we sum two independent negative binomial distribution, then we will get another binomial negative binomial distributions.
I can't comment actually. I need to cross check. If you are asking about additive property of negative binomial, I need to
Yes,
cross
sir. It's
check to
additive
answer.
property
Yeah.
and the negative.
Yeah.
Yes, sir. That the answer will be the negative binomial distribution, but I am not getting the mathematical expression, sir. I have asked the
Actually,
doubt in the madam, but the madam did not come today.
Okay,
So
no
now I
worries,
am
no
asking.
Subhankar, no worries. So what you can do, you are asking about additive property for the negative binomial, right? Do one
Yes,
thing,
sir.
just tag me on discourse. I will check and let you know. Actually, I can't recall the exact formula, but this additive property and all you can do with the those things we are going to discuss later also. That's called moment generating functions, right? So with the help of MGFs also we can find these kind of things. Okay.
No,
But
sir has given us 4 homeworks, out of which this is one of the questions.
Oh,
sir,
no
in the
problem. Just
week
okay.
2.
Okay, no problem. Just tag me on discourse. I will write the solution and post there. Okay.
Okay, sir.
Oh, yeah. Okay. I think that's all
Sir,
from my
who
side.
will take the next session?
Most probably I will take as of now.
So you will take.
Yeah.
That is a solve with the session.
Yeah, solve with the session. Mainly, I will.
Yes, yes.
We will come up with some set of questions. We'll try to.
Sir, why
Whatever the
didn't you
thing.
come
Yeah.
after the first session?
Sorry.
Why didn't you come after the first session?
Actually, I was busy with other things, so that's it.
Oh.
Sir, would you please provide that PDF in which
PDF, yeah. So I will share with the support team. So I don't think they will upload by tonight. Maybe tomorrow they will upload. Okay, tomorrow. Okay.
Sir, why don't we stream all the TA sessions as well?
Yeah, Rahul. So the idea behind TA session actually is something like
Yes, sir.
that.
In every subject we have TA sessions, but in the statistics too, there is no TA session.
No. You need to check your calendar. There are TA sessions. So
we're not streaming.
all TA sessions we are not streaming. I mean, this is my personal view actually. So actually, see, some of you are not able to ask doubts. They hesitate. For asking the doubt when things are live, right? Or things are recorded.
Okay.
So if you are not recording, so okay. Why is that so? Sometimes people think, yeah, this is very basic doubt whether I should ask or whether I should not ask. Okay.
Okay.
If we are not recording or some session or we are not streaming it, so you will feel free, right? So whatever the thing, that's the idea. But sometimes we are recording also. If we feel let's we are going to do PYQ session, those kind of session for sure we are going to record and okay.
Okay, yeah, makes sense.
Oh,
Prashant sir, one more question, sir.
Hmm.
Sir, regarding this week 0, sir, is it important for exam?
No. It's not important. Week 0 is just brush up on concept for
Yeah.
Prashant sir,
yes.
some of us are working professionals and it becomes difficult to follow through the TA sessions everywhere. So probably it would be great if we can record those sessions.
Yes, sir.
Yeah. So I told you, right? So not every session we have recorded, but the sessions which are important. So actually, I think last the sessions which TA did in the last week is all are recorded, right?
Yeah, though it is recorded, it gets uploaded a bit late. So
No, actually, okay.
Yes.
One more thing. Whenever suppose I'm going to record session only, right? So it will take some time to render and upload on the calendar. Okay. So that's why suppose they have done the session today. So you can check tomorrow morning. That will be because once it will be, I will get the video. I have to give the access. Okay. So it may take some time. It will
So
not
that's why it's
happen
better
as
to have it on YouTube.
okay. We'll discuss with the
Yes.
TAs and all. If that is okay,
Yes,
we
please.
can stream it. Yeah.
I think
Yes, sir, that should
Thanks
be
for the
streamed over
suggestion.
YouTube.
I think currently not all of them are uploaded. Can we check that? Double check, maybe offline.
You can check from the calendar. It's not any of the session which happened till now. It's on YouTube, but recordings are there. You can check from the calendar.
Okay, thank you.
Okay, yeah.
Thank you, sir.
Thank you. Okay. Thanks.
Thank
all.
you. Thank you.
Okay, thank you.
Thank you,
Hope
sir.
you got the idea for week 4. Yeah, thanks.